Question. Five identical charges Q are placed equidistant on a semicircle as shown in the figure. Another point charge Q is kept at the center of the circle of radius R. Calculate electrostatic force experienced by the charge Q. Let us consider XY coordinate system. In that, at the origin we placed the charge small q, and there is a semicircle, and there are 5 charges placed at different position. Let us name their values as Q1, Q2, Q3, Q4 and Q5. Though we named them as Q1, Q2, Q3, Q4, Q5, they are all having equal magnitude. Their radius is capital R, and Q2 and Q4 are at an angle of 45 degree. Now let us find the force on small q by Q1. It is F1 vector in the direction of negative y-axis. We find the force on small q by Q5. The force will be in the direction of positive y-axis. These two forces are equal in magnitude, opposite in direction, so they cancel each other. Let us find what is the force on Q by Q2. It will be F2 vector. This F2 vector is resolved into two components. One is along negative y-axis, another one is along positive x-axis. Now let us find what is the force on Q by Q4. It is F4 vector. We resolve this into two components, F4 along positive y-axis and another F4 cos 45, that is along x-axis. Now the vertical component of F2 and F4 are equal in magnitude but opposite in direction, so they cancel each other. Finally, what is the force on small q by Q3? It is F3 along x-axis. Now there are only 3 forces available along x-axis. They are added. When you add these, we get the total force available on Q. Solution. Though based on their position, we named them as Q1, Q2, Q3, Q4 and Q5. They are all having same magnitude. Force acting on small q due to Q1 and Q5 are opposite in direction, so they cancel each other. So F1 vector plus F5 vector equals 0. The vertical components of forces F2 vector and F4 vector are equal and opposite, so they cancel each other. Horizontal component of the forces F2 vector and F4 vector are equal and in the same direction, so they get added. So F2 vector plus F4 vector equals 2 times k q q2 by r square cos 45 I cap. Q2 and Q4 are equal in magnitude, so 2 times you get horizontal component. So it is 2 k q q2 by r square cos 45 I cap. Let us replace cos 45 as 1 by root 2. 2 and root 2 they cancel and we get a root 2 on the numerator. So F2 vector plus F4 vector equals root 2 times k q q2 by r square I cap. The force acting on small q due to Q3 is F3 vector equals k times q q3 by r square I cap. The total force on q due to Q1, Q2, Q3 and Q4 is F vector equals F1 plus F5 vector. We have seen that F1 vector plus F5 vector equals 0 and F2 vector plus F4 vector together we found that it is equal to root 2 times k q1 q2 by r square I cap plus F3 which is equal to k times q3 by r square I cap. So let us add all these quantity. Final answer is F vector equals kqq by r square root of 2 plus 1 within bracket I cap.